Hello guys, my name is Mateusz Mazurczak and I am the team's programmer. Today I want to talk about how the code works, how our entire mission's code will function. So let's get into it. Over here is how the UI looks. This is what is used to display all the data during the mission, and I will explain in a separate video how exactly it is used. But right now we can just see you have a chart showing historical altitude reading. You have some kind of map, maybe showing where we are located. This map is dynamic, so it shows whether it gets GPS location or not. The center is where we are right now, roughly located. The GPS is transmitting from inside the house, so the precision is not super great, but it's pretty close. It's quite close, I'd say 20 meters maybe. Over here is all the data about what is going on with the device. Also this, right? So altitude, every piece of information, which I'll explain in the other video, and also this stuff, which is not fully coded, but well, we are getting there, right? So how does this function? Well, let's start by saying how this is structured. So we have our front end, and this is written obviously, HTML, JS, CSS standard stuff. Over here, this will communicate via fetch request with a local server running in, it's locally running here, you can see all the time, running in Flask in Python. And this reads data, this Flask server in Python reads data via a COM port, COM11 to be precise, but it doesn't matter. It reads data from our local ground station. This is a module which is the same one as we use in our CANsat, and this one reads data via LoRa to our CANsat here, and this information transmitted via LoRa, it's parsed here. This is the code for what's running on the CANsat itself, right? This code goes through LoRa to our receiver. It displays this data through the serial. It's running on the actual hardware external to our computer, which is connected to our computer via the USB port read by the Python script over here. And then this Python script parses this. And finally, it sends it to our nice here renderer of this information, which looks very nice, but actually it has certain dark secrets. Look, it's not responsive. How terrifying! But that's because we don't have time to code it responsively. You know what I mean? Normally to resize, but this is okay. We don't want it resizing. We want the people to have to put it in full screen. It looks very good now. You have the most screen available and information available because there's not enough time to code everything so well. I want to debug the concept to make it work better than spend time aligning elements. But you can see here how this was made. It was made in XD and was aligned without using the dynamics. Obviously, we could also align it using a nice, maybe you do front-end design, maybe you want to do it nicely and have it centered and stuff like that, which obviously we can do, but again, not enough time. We have to have everything assembled by the end of the deadline. But so far you can see it's working quite well. This is all gonna be in the Git, so you can check it out. We set the root color. This is an interesting thing you can do in CSS if you didn't know. How do you send the data? Well, there's a constraint. You can have only 20.4 characters per second sent via the LoRa. This is not very good. We want to have more, so we send 20, right? But 20, well, what does it mean? Well, there's one null character and there's 19 characters you can work with. Characters, so they are byte values. 255 from 0. Nice. This is what we have to work with. How do we make do with this little data? Well, very good question. We use this over here, and how we encode it. This is on manual. You can read also how this functions. You can see how it works. It's just encoded as a string like this, and this string, it contains data. For example, we don't have enough place to send both latitude and longitude coordinates. If we want to get good precision within 10 meters, we need to send 11.1 meters technically on the equator. We want to send exactly 4 decimal places, which is a lot because then you need to have three decimal places. I mean, 3 left side of decimal places, right? In integer values for everything, which means 7 values, which we can't send enough. In one transmission. 14, too much, we can't do that, very bad. Plus also plus minus sign, not good. So what we do is we split it into 2 transmissions. Every transmission, we either send latitude or longitude. So if the GPS were to change log, you would see it moving like a staircase, kind of, right, down, up, because it's sending either latitude or longitude. This is the best way of having it refresh. You don't need better precision, because remember that on board the CANsat, the SD card still stores exact readings all the time. But to the ground station, you send either one or the other, which works very well. This entire thing is just very heavily encoded, and that way, for example, the speed, which can be from 0 to 36 meters per second, roughly, the ground speed via the GPS, it's encoded either as symbols or as characters. You can see over here. Either it's encoded as a nice a symbol or a number, because a digit, right? Because then you get perfect function. This is explained here, so you can read through it. And again, I'm gonna do this nice video on how the UI functions exactly if you want to use this in a project or something. But that's how it works. Nice. Another thing to go into, maybe how this functions, to show exactly how we use Mapbox and how we use this stuff. So over here is the get function, just uses this local server. This local server just sends a JSON. I think if you go onto it, it will show you the JSON. Let's try. I think, but I've never tried that. It should show you some kind of JSON. Come on, you can do it. It's not fetching, so it might not work. Okay, I don't know. It's not showing you anything. Maybe that doesn't work, but I hope it didn't glitch itself. Did it glitch itself? Oh, it's still working. Alright, so it's a GET request. Oh, I'm dumb. Yeah, the browser will not display, but you get the idea. Simple stuff. Postman would explain, but Postman is obsolete now on the new hardware because Chrome turned off Postman. Long story, just it was an extension for Chrome, very useful, but no longer exists. So you can see that's how we do this part. Over here, you can see how the chart works. We use Chartist. We define the chart like that. To have this nicely switch between modes, we just set opacity for them because nothing is clickable, so you don't have to have a click-through issue. You just set opacity. If you had clickable elements, you have to just display 0, but opacity is just easier, again, because I have little time to code this. My gosh, I have to, but it works out. Over here, you can see how it works. And also, we have how it will get our map, so Mapbox, but I didn't talk about chart yet. So Chartist is just here, fairly simple stuff. And also the circles are defined in a nice way. This is also fairly easy. You can look at it, you can use this in your code. This is some kind of very defined method for using it. I think this is from MDN Mozilla Docs. I think I found this there, but I mean, I coded some of it, of course, but I stole half of it as well. No, I mean, yeah, that's how it is. I just know I use the documentation for Mozilla, right? But anyway, so that's how it works. I think this is everything I want to go into. I hope you understand, and I hope you have enjoyed it. Have a good day, and good luck coding.